Hello everybody, welcome to day 2 for credit 8. Um, just starting out here, we look at these two animal populations. So P and Q are giving the sizes of these two different animal populations, and Q is a greater or a larger population than P. So in these A through F, uh, which pair of given the pair of expressions, which is larger? So just a little hint on this one. So Q is greater than P. I would put a real number to these to try to test this out. And since we're talking about animal populations, they should both be positive numbers. So just put in 2 is greater than 1, right? So I'm going to say Q equals 2 and P equals 1. And I think that if you plug that in for any of these, you could quickly see which is going to be greater, or in some cases they may be equal. Actually, so if they are equal, you might test another number, right? So test something like Q equal to 50 and P equal to 1. Yeah, that'll get you going on that one. Seeing the dots, consider the algebraic expression below. Use these figures below to illustrate why the expressions are equivalent. Okay, so this is n plus 2 squared minus 1, or minus 4, and then n squared plus 4n. So you might look at this as, so if this is step 1, right? So this looks like n plus 2, so that makes it a square, right? N plus 2 times n plus 2 would be n plus 2 squared. And then you take away 4, so I'm taking away these 4 here. And you can see the same thing here, the n plus 2, so even though it's 2, we're multiplying 4 times 4 and then taking away 4. So that fits that expression. Now, thinking about it this way, so n squared plus 4n. So n squared would be 1 squared, which would be the middle, right? And in this case, it would be the middle part, plus 4n, so plus 4 times 1. Which would be adding those 4 on there. And then over here, we have n squared plus 4 times 2, right? 4 times 2 would be those on the outside, right? So you can kind of think of it that way, that there's two different ways to express the same thing. So multiplying binomials in a two-way table, I like doing it this method because it really relates it to this sort of area model. That we have 5x's times 2x's gives me 10x squared, and then 5x's, so you multiply the column times the row. 5x times 3 gives me 15x, and then 2x times negative 7 is negative 14, and then 3 times negative 7 gives me negative 21. And then you combine any like terms. So this would be negative 14x's and positive 15x's would make positive 1x into that expression there. Okay, so you're going to go ahead and multiply all of these using that idea. So put 1 on the top and 1 on the side, and then multiply each of those components together and come up with an equivalent expression. And then combine any like terms before you put your final answer. So here, equivalent expression here, where I want to find the a value. So what is the coefficient on x squared when I multiply these two together? And you can do your own little box on the side, you know, with 3x plus 2 and 2x minus 5. So what is the value of a in this case? So I'll just do the x squared part. So 3x times 2x would be 6x squared. So this 6 would be the value of a, because it's going to be the x squared. Now, the value for k is going to be a little bit tougher because you're going to have two parts and have to combine like terms. But go ahead and justify your answer there. And then we come upon this question where we're talking about quilts made, square blocks for quilters. Okay, so Optimus Quilts has decided to produce several new lines of rectangular quilt blocks. So they're gonna do it by adding on to the side length 5 inches on one side and 2 inches to form the other rectangular block. So you can kind of picture it like this. It has some length x. This block has a length like this, x, and then they're going to add 2 inches on to one side and 5 inches on to the other side. So this new area looks something like this. And so the area of each of these parts will be basically the area of this new rectangle is x plus 2, right? This length plus this length is x plus 2, and this length plus this length is x plus 5. So the area of a rectangle is just the length times the width. So you can look at it that way, and then can you find a different expression to represent the area of this new rectangular block? Well, we just looked at some ways that you can find equivalent expressions to that expression, right? Multiplying those two together. So then this looks at a couple of similar problems. So you have the original square block and it's extended by 3 and by 4 on the other side. So what is this new representation? So 3 and 4 get added on to the original square block. So 4 and 3, and this is x and x, right? So you would do it the same way there. So you have to make your own expression. And similar with these other two. Okay. I think more of the same there. But now we're decreasing instead. So you can think of this original square block, but then we're decreasing. It's the same as x, and then I'm going to take away 2. So it's minus 2. Now we can deal with negative area if we just stick with the symbols. And then we can multiply it the same way and come up with an area that's the length times the width, right? Length times the width. So if it's some distance minus 2 is a length and some distance minus 3, or whatever they do. I guess they're extended by 2 inches. Oh, so it's extended by 2 inches on one side and decreased by 2 inches on the other side. Well, it's still the same thing. You're going to take whatever the length is times the width, and so it's plus 2 instead of minus 3. So that's the idea. And then I think this is just combining like terms. Go ahead and read that and do the problems associated with it. So then here, finding the sides of the rectangle. So what do you think the sides of the rectangle are? So we have, x plus something and x plus some other thing. What works to make this this expression work, right? X plus something and x plus something else. So to make it, I'm going to multiply these two to get 18, right? And then x times something, and then x times something else, those are going to add to 9. So try to come up with what values the area gets extended by that would make it an equivalent expression to that. So it's x plus something times x plus something else is equal to x squared plus 9x plus 18. So find some value that would go there and there that would make this statement true. Okay, that's your hint. And more like that, and then you have to fill in your notebook. Okay.